Alright, in this video we are going to look at two examples on solving complex fractions. Now when we're talking about complex fractions, what we're actually talking about is we are talking about a rational expression that has a fraction expression in your numerator and a fraction expression in your denominator, kind of like this one here. So the easiest thing to do is you are going to approach this as if your numerator and your denominator are two totally separate problems. Okay, so the first thing we're going to look at is the top, and what this is going to allow us to do is we are going to be able to rewrite this expression into a brand new rational. Okay, so let's go ahead and look at your top. So we're looking specifically at 1 over the x squared minus 1 over y squared. Now the first thing we need is we need a least common denominator. So I have an x squared and a y squared in the bottom. That means my least common denominator is x squared y squared. So when I redo this rational, I'm going to have x squared y squared is my denominator. For my first part, I'm missing the y squared, so this becomes y squared. I'm still subtracting. In the second part, I'm missing the x squared, so that's my new numerator. So up here, we're going to end up having y squared minus x squared all over x squared y squared as my new numerator. I'm going to do that exact same thing to the denominator. So let's go ahead and take a look at my bottom fraction. So we have 1 over y cubed minus 1 over xy squared. So again, we need to have a least common denominator. In this case, I have 3 y's on one fraction, I've got 2 y's in the other, and I have an x on one side but not on the other. So xy cubed is going to end up being my least common denominator. So my rational over here is going to have xy cubed as the bottom. If you look at this first piece, I already have the y cubed. What's missing is the x, so this is x minus. On my second, I have an xy squared. I'm just missing one more y, so minus y. So my denominator here is going to be x minus y over xy cubed. Okay. So now what I need to do is I need to work on reducing. So when we reduce, we are going to keep the numerator the way it was. So y squared minus x squared all over x squared y squared. And instead of having it be a rational, we're now going to multiply and we're going to flip the reciprocal of the bottom. So this becomes xy cubed all over x minus y. Okay. So we're going to work on reducing this mess. The first thing that we are going to focus on is we are going to focus on this diagonal piece right here, as it is going to be the easiest piece to work on simplifying. Okay. So first and foremost, I have x squared on the bottom and an x on top. So these are both going to go away, and what's going to leave behind is it's going to leave behind the x on the bottom, but no longer on the top. Now I have a y squared on the bottom and a y cubed on top, so these are both going to go away, and what's left behind is just a y. Okay. So when we look at how this looks, we now have y squared minus x squared all over x times y over x minus y. Okay. Now the second thing that we need to work on is we need to kind of start working on this diagonal here, going in this direction, because there's nothing else for me to do the other way. The first thing that I want you to notice is that my terms are in reverse of each other. In the numerator, I have y minus x. In my denominator, I have x minus y. So the easiest thing to do is in this numerator piece right here, we are going to pull out a negative 1. So when we do that, this is what happens. We pull out the negative. If we look at this, this was positive, so this becomes a negative y squared. My x becomes positive x squared. Well, that looks funky, so we're just going to go ahead and rewrite it to be negative x squared minus y squared. Okay, so if we look between this denominator and what my new numerator would be, my x and y terms are going in the same direction now. So let's go ahead and rewrite that. So here we ended up with negative x squared minus y squared all over x, and we're still multiplying that by y over x minus y. We are still working across this denominator, or across this diagonal. The first thing that we need to notice too is that this right here is going to be a difference of squares. So you're going to use your difference of squares formula, and what's going to end up happening is we have negative, and this is going to be x minus y times x plus y. This whole thing is over x, and we're still multiplying that by y over x minus y. If we go back once again to looking specifically at this diagonal, one of the things that you should notice is that I have an x minus y on top and an x minus y on the bottom. Once those cancel, what we are left with is, if we combine, we have a negative y times x plus y all over x. Now if you take a look very carefully, notice there's nothing else that I can do here that is going to simplify this in any additional way. Therefore, we've reduced everything down as far as we can, and we are done. Now let's take a look at one additional example just to make sure that we have a firm understanding on what we're doing. So again, we're going to make a new rational. We're going to look at the top and the bottom as separate problems. So here, if we look at our top, we are looking at 1 over y minus 1 over x plus 3. So here, my least common denominator is going to be y times x plus 3. So if we look at the first part, we are missing the x plus 3. So this is going to be x plus 3 as my first part. I am subtracting, and in the second part I'm missing the y. Okay, so that is my numerator. So here we are going to end up with x plus 3 minus y all over y times x plus 3. And now we need to do the denominator. So we have 1 over x minus 1 over x squared plus a 3x. The very first thing that we want to do here is we want to simplify this denominator. So to do that, says I can pull an x out. So this is x, and what's left behind is x plus 3. Now the reason this is important is because it's going to help us write that least common denominator. So in this case, what we actually have here is we have 1 over x minus 1 over x times x plus 3. So just like with the top one, our least common denominator is going to be x times x plus 3. So when we multiply that through, what we're going to get is that our denominator is x times x plus 3. I already have an x on my left hand side, so I'm missing the x plus 3. I am subtracting, I already have x times x plus 3 in my denominator here, so what we're subtracting is the 1. Okay. Now with this, we can actually reduce this down, so what we end up with is having a denominator of x plus 2 over x times x plus 3. Okay, so let's go ahead. So we've got our new fraction. Okay, with that, we're going to reduce in the same fashion we did before. So when we reduce here, we're going to keep the numerator, so x plus 3 minus y all over y times x plus 3. We're going to change to multiplication, and we're going to flip the reciprocal of that denominator. So this becomes x times x plus 3 all over x plus 2. The first thing we're going to look at, just like before, is we are going to look at simplifying. So we're going to go ahead and go with this diagonal, and we are going to reduce out what we can. So what you need to notice is that we have an x plus 3 both in the top and bottom, so we can reduce that out. In doing so, what we are left with is x plus 3 minus y all over y times x over x plus 2. Now here, there's really nothing else that we can see to do. So what you would do here at this point is you would go ahead and multiply straight across. So we're going to end up with x times x plus 3, sorry about that, x plus 3 minus y all over y times x plus 2. Okay. So again, let me write that so it's a little bit more clear. When we multiplied, we ended up with x times x plus 3 minus y all over y times x plus 2. Now we can leave this in its factored form, or if you really want to, you can distribute through, which would give you an answer of x squared plus 3x minus xy all over xy plus 2y. Okay. So pay attention to how you are supposed to give your answers, whether you want it in complete factored form or you want it to be put together. Okay. Otherwise, there you have it. That is one way that you go about reducing complex fractions or complex rational expressions. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed this video, and I'll see you next time.